very good evening, everyone. So I am hoping that all of you have registered for our hackathon. Nikesh will be posting the link on the chat. In case you haven't been aware about our hackathon, which is on plastic detection in reverse in association with Kindle, we have been getting very overwhelming response from all of you, which is excellent. We also have a very active Discord channel where we are getting a lot of inquiries and questions about how to go about on this hackathon. And we have been doing a set of support sessions. Today's session is very key because we have one of the judges who is going to judge your work, Usha Rengaraju, is going to help you understand what are the ways in which you can do object detection or segmentation. We are not promoting any methodologies here, though the challenges on object detection, you may choose whichever the methodologies, but for a beginner, how do you go about starting the work? What kind of tools are available? What kind of frameworks are available? What kind of maybe the kind of deployment submissions that we have asked, all that also will be discussed today. It's going to be hands-on. She may show some of the methodologies, but in no way she is promoting a right approach or the best approach. It is just to give you some understanding on how to look at this problem statement and compete in a competitive environment where we are looking at somebody who is able to predict accurately. So MAP is going to be one of the biggest metric that we are looking at. So she's going to look at some of the state-of-the-art algorithms and frameworks and how to submit, because one of the ask from our end is that you must submit your code in an ONNX format. Some of you have reached out to us about it, so she will also discuss. And we are looking forward to your Q&A during this session. Please do post. She has also posted a set of Google Sheet with a lot of links. If somebody is very new or somebody is maybe an intermediate, please go and check those resources as well. And looking forward to a very interesting session. About Usha, I'm sure you would have looked up about her in internet or LinkedIn. She is first and foremost, she is our mentor at Reva Academy for Corporate Excellence, where she trains our working professionals on various areas of machine learning and deep learning. She's a chief research at Exo Protocol. She's one of the very rare women polymath, has been ranked as top 10 women tech leaders by Raise. We have a annual award function that which we have honored her. She is one of the top 10 women data scientist being awarded by various agencies. She's very active in promoting and supporting people across universities and students and working professionals. She is a polymath. That means she's very well versed with multiple areas. She's I would say that the way she solves the problem, she stands for speed and accuracy and efficiency. I think we have seen some great work she has been doing at this very young age, and we look forward to your guidance and looking forward to a great session. Usha, over to you. Thank you.
Yeah, thank you so much, ma'am, for the great introduction. And yeah, it's my pleasure to be part of this event, seminar, and be part of the hackathon as a mentor and judge. And now let's get started with the session. As ma'am said, we are not, covering anything, as a best practices, and this is the approach and all that. We're just covering the basics of object segmentation and object detection for absolute beginners, who have not previously dealt with object detection and segmentation. We're just making it easier for them so that, they can get up and running in no time. So I've already shared this thing, the materials which we will be covering. This is more of a hands-on focus session. So we'll not be like covering much of a theory. So yeah. And the session is for absolute beginners. So now YOLO is one of the top performing models right now. And when it comes for object detection, I think YOLO ranks first in most of the Kaggle competitions or in any of the hackathons outside. I think it's more one of the YOLO variants are the best performing architectures we've got right now. So what we're going to see now is we're going to see how to make inferences using this. The first notebook deals with how to make inference using YOLO V8 model and how to take some random images and how to use pre-trained models for making inferences. Why this is important? This is important because the GPU is a limited resource. The team is going to give you GPU hours, but you should make the best use of it. So you should know how to use the pre-trained models and make predictions and do fine tuning and transfer learning on top of it. So that is why this tutorial is being covered. So yeah, YOLO stands for you only look once, and these YOLO models are developed by an organization called Ultralytics, and you can just go to their GitHub repository. You'll have multiple variants from this. This has been an evolution of models. So there was YOLO Darknet, YOLO V2, UV3, and there were multiple variations of YOLOs which has come out, and all those variations when they had come out, they've been the best performing models at that point of time. When YOLO V8 came, YOLO V8 was the best performing model. So at every iteration of models which they released, they were the best performing benchmarks at that point of time. And YOLO was adopted very quickly by the community for the ease of use as well. So yeah, now if you want to use YOLO, then you'll have to do pip install Ultralytics. You can go, or you can do a GitHub install of their directly their GitHub account as well. So pip install comes in very handy. So you can just do pip install Ultralytics, and you can install all the YOLO version of models, and then you can do an import Ultralytics to get up and running with YOLO models in your Google Colab. So there are multiple variations. You can go look at YOLO V8 docs for using all the possibilities. We won't be able to cover all the possibilities in a short sessions, but then YOLO V8 docs, and if you want to look at the docs of other models which has come out like YOLO V5, and you can also look at the Ultralytics hub where you will get all the possible models like, you have YOLO V3, 4, 5, 6, 7, 8. And you also have got recently segment anything model, fast segment anything model. And you can also go for real-time detection transformers. So there are a lot of models out there in Ultralytics. And all of these are best performing benchmark models. And and it comes these are very, very easy to use as well. So you don't have to be such a strong expert in all of it to use. You can just go through these documentations and get started in no time. And to get started with to use YOLO models in your Colab notebook, you'll have to install Ultralytics, which is what we saw. There are other three options, like you can use Predict. You can take any image, random image, and you can just make a predictions using YOLO V8 without even training. You can just make predictions on the fly with the pre-trained model. And what if you have your own custom data set, and then you want to train the YOLO V8 model on the custom data set and predict? There's one option for that also. And YOLO V8 is not restricted to object detections. You can do other tasks like image segmentation. You can also do tasks like key pose detection, and there are plenty of other tasks which you do using YOLO version of models as well. So now let's look at some of these tasks. To start with, we have imported Ultralytics, so which means we can start consuming the YOLO models. And now the first thing comes is Predict. So I'm taking just the Ultralytics itself, website itself has got image. I'm just using that image itself, but you can replace this image with any other image as well. So it is very, very easy. So there are two options. You can use a Python, you can make a prediction in the Pythonic way, or you can make the prediction in a CLI way. So CLI way is mostly a command line prompt. So here we are just using the commands like, YOLO, exclamatory mark YOLO is a command, and the arguments which are going is predict, which means we are going to predict an objects in the image. And the model which we want to use is, we want to use this pre-trained model YOLO V8 and .pt. You can replace this with other YOLO variants as well. And then source is where you give your source image where you want to make object predictions. So it is as easy as this command line version of implementing, making a prediction using YOLO V8 model. So it boils down it's to a single image, a single line of code. You have not written any lengthier lines of code, nothing. So this anybody can do it, and you don't have to memorize it. All the syntax and everything is given in the Ultralytics website, where you can just go click on it and you can see how to do it. Predictive click, how to do predict and all that is given in the Ultralytics website itself. So you don't have to memorize the syntax and things like that. So you can just make a prediction using just a single line of code. And so yeah, here it is done. This is Ty, this is a person, this is another person. So we are done with the first task. The second task is going to be, so for example, you have a lot of trained models. Ultralytics comes with huge versions of multiple versions of YOLO variations. But what if you want to see the performance of these pre-trained models on a particular data set? If you want to see the benchmark it on a particular data set, how do you do it? So that is what is going to be the next thing. Here it is going to be a benchmarking on the core code data sets. You can retrieve from the Ultralytics itself, you can retrieve the validation part of the COCO data set, validation, or you can download the test data splits as well. And after you download it, this is torch.hub.download URL, which will download the validation data sets for you. After you download it, you can just unzip it. That is what this piece of code does. So here you have this COCO data set where there are multiple classes like Thai, suitcase, cat, dog, and these are the classes which are available in the COCO data set. So to do a benchmarking on the validation data set, what you do is again, we're going to show a demo using command line. So exclamatory mark YOLO, you're saying validation, which means you're going to benchmark the performance of this pre-trained model on a validation data set. And so the model again, which you want to test out is YOLO V8. And so you write what model you want to do benchmark testing on. And then you mention the YAML file of this validation data set. So that is what the data is, this validation data set. So that YAML file is what you mentioned. All you have to do is a single line of code and you will be getting the benchmark on the validation data sets of COCO. It's all done. So it's just a single line of code and you can accomplish a lot of things straight off the fly. And what if you want to train your models, models, then you have, again, the syntax is YOLO, exclamatory mark YOLO. And instead of validation and predict, you'll be mentioning train as the argument here. And the model which you want to train from the scratch is YOLO V8.pt. And on which data set you want to train, you can use COCO. And then there are multiple other parameters as well. So if you go to this YOLO V8 docs, then for train, what are the other parameters which are available is something which you can say. YOLO also has, it's not necessary you should use just COCO. You can also use VOC, ImageNet. YOLO has multiple other data sets as well. So you can point it out to other data sets and see how the performance is, how these lines of code work and all that. So again, if you see arguments of train, there are multiple other arguments, model, data, epochs. So there are multiple other arguments. So you can go to the documentation, see what all these arguments means and what are the values these arguments accepts as well. So it's not necessary you should give values to all of these arguments. Whatever is relevant for your use case, those values alone you can give. And what are the valid set of values is being given under the value argument. So you can go and explore this as well. So here there's only the image size and the epochs are given, and just for just it's trained for 3 epochs because the GPU constraint is just trained for 3 epochs, but for your use case you might end up training for multiple epochs. And so this is how you use train, and how to use the arguments of the train and all that. And as I already said, we'll be discussing, ma'am said we'll be discussing how to export YOLO V8 to another format. So here, since your format is ONXS, YOLO V8 comes in very handy. It's just a single line of code where you just have to do YOLO after you train your model, exclamatory mark YOLO, export with the model which you wanted to export. Here is YOLO V8, and then you just have format is equal to dot script. Instead of dot script, you just have to put ONNX, or you can put any of these things. It supports conversion to all of these model type, all of these different types. So here, instead of dot script, you can put ONNX. That's all. So that's how you can convert a YOLO V8 pre-trained model into the format which you want. So it is as simple as this. This is going to be very easy for conversion to, even if you're using Keras framework or TensorFlow framework, or if you're using PyTorch framework, conversion to ONXS is going to be very simple. So for Keras, there's a Medium article which is written here, which you can check how to convert your into ONXS format is something which you can see. And the same thing for TensorFlow as well. Irrespective of the framework which you use, there'll be a utility function which, for the famous frameworks, there's a utility function which you can use to convert it into ONXS format. ONNX format, and this is so simple and very very easy, just a single line of code in YOLO V8. So what if you don't like the command line of exclamatory mark YOLO doing things like that? What if you want a Pythonic version of doing things? Then you can do it using the Pythonic way as well, where you do model.train, model.val, how in a Python based frameworks, how you use it instead of doing a command line. But this is a lot of lines of code. But if you prefer this, then you have option to do this way as well. So you can just, if you want to build a model from scratch, you can use this. You have to specify the YAML file. If you don't want to build a model from scratch, you just want to make predictions using pre-trained model, you can use the second line. And then it's going to be the easy model.train. You mention what data set you want to train it on, and then number of epochs, and then model.val is where you make the performance, you see the performance on the benchmark data sets, and then you can randomly predict on an image. So this is for people who like the Pythonic way of things. And see, YOLO version of models is not just for object detection. You can also do image classification using YOLO version of models. You can also do image segmentation. You can use image tracking, key pose detection. These are various things which you can do in YOLO version of models. So there is a sample code which is written on how to do all of these tasks. So for object detection, again, I'm doing from Ultralytics, I'm importing YOLO. The model which I'm using is YOLO V810. Then just take the COCO data set, and then, take an image and make prediction on it. So this is all is for object detection. And for segmentation, it's going to be the same thing. So instead of taking YOLO V8.pt, you're going to take the segmentation model, corresponding segmentation model, pre-trained segmentation model, and then you can make predictions on a random image. So this is how you can use a pre-trained segmentation model from the YOLO website, Ultralytics website, and use it to make segmentation on a random image. And what if you want to do classification? Then that's also covered. From Ultralytics import YOLO, you are just going to use the pre-trained model for the classification. And then you can train the data on, for classification, you can use different data sets like MNIST or whatever data sets you want. You can mention the data sets which you want to train on, and then make predictions. So what if you want to use key post detection? Then you use, the YOLO V8 pre-trained model for the key post. and then you can train it on whatever data set you want. You can use Coco, or you can use other data sets which the Ultralytics website supports, and then you can make predictions. So this is how it's not YOLO V8 models is not restricted to object detection. You do various other image related tasks like classification, detection, segmentation, tracking, and key post detection. So your Ultralytics has got a very detailed website, so you can go to the websites, because all of this single command line has got various other parameters. You can explore all these parameters to get better performance and improve your models and all that. So this is how you can get a lot of tasks done just using pre-trained models. It is very important because most of you may not have higher end GPUs with you, and you want to get tasks with minimal GPU, whichever you have, or the free Colab resources or the free Kaggle resources, then the best thing is to use a pre-trained model. So now we have seen how to make inferences on a random image using the pre-trained model. What next is, in your use case, you're going to have a custom data set which is reverse with containing plastic, and you have to train the YOLO V8 models on the custom data set. So how to do that is what we're going to see next. So there is a website called RoboFlow. So what you will have to go to is there will be a line of code. If you please don't run this right now, because it will take really long time to complete running. But if you have a good GPU, it might get finished faster. But if you're doing it in Colab, then it's going to take really long time. So there is one piece of code which you need to change. Here it's asking for RoboFlow API key. So this is something which you need to give. So you can sign in here. You can sign in using your go to roboflow.com. I'll put the website in the doc. So and I also put it in the chat window. So RoboFlow, here you have an API key where you will have to go to the website, and then you will have accounts here, settings here, and then you will have to go to workspaces, new workspace, and you will have RoboFlow API, where if you click on it, you will be able to get your private key. You will have to copy this. So this is how you will be getting. You'll have to go to accounts, workspaces, RoboFlow API, and you will get your private key. So that key is what you need to copy, and you will have to place it here, your API key. Only after doing this, you'll have to run this notebook so that it runs. It's going to take really long time. So don't try to run while the workshop is happening. Maybe later when you have a good GPU, you can run it there. And then we are going to get started now, how to do the YOLO V8 training in a custom data set. So here, the first command which we are using is NVIDIA SMI. This is to see if you are using a GPU to see if your GPU is enabled or not. So here, when you give this command, you can see if the GPU is enabled. And if GPU is not enabled, you can go to the runtime and then you can manually enable the GPU. And the next thing is we're just going to the current. Just give me a minute.
In the meantime, can you post your queries? We can see one query which says that video Sri Shanvi. Is there any other questions? Can we see a raise of hands of those who are using YOLO V8 models? Or any update on? Yeah, okay. Some hands are up. Yes. That's good. How is your accuracy and all that coming up? Maybe some conversations around it. That will be good.
Yeah, apologies for the delay. There was some urgent call which I had to take. So now I'm back. So this is how this notebook is about how to do a custom training on a custom data set. So the data set which is given to you is a custom data set, which is not a standard benchmark data sets like COCO or VOC and all these things. It's a custom data set. So how do you use YOLO version of models for a training on a custom data set is what we are going to see up next. So this whole notebook is what you use it. I'm also going to cover how to use RoboFlow just in case if you are doing your own annotations. There are some free tools like RoboFlow out there. So RoboFlow might be paid after certain number of things. It may not be completely free. So there are multiple other free websites out there which you can just Google out. You'll get the list of websites where you can do free annotations. So you can use any annotator tool of your choice. And so this notebook will also cover how to do annotations as well. So now you just check whether you are connected with GPU, and for that the command is exclamatory mark NVIDIA SMI, and then you also can check which directory you're currently in. So currently you are in content. Whenever you use Google Colab, you will be in the directory content, but the default directory will be /content. And then you can install Ultralytics. So again, to install Ultralytics, it's pip install Ultralytics, which you've seen earlier as well. And after you install Ultralytics, you can import YOLO, and then you can import the other Python utility functions which you will require, like image, other display, and other utilities which you will require for this particular use case. So from CLI basics, we have already covered in the previous notebook, like you can take do YOLO exclamatory mark, and what is a task which you want to do. If it's segmentation or object detection, you can mention it there. And what do you want to do? You want to do prediction or you want to train your model. So you can put the mode as predict, and the model is YOLO V8 seg PT, and then you can give a random image and you can see the performance of it, how it does segmentation for you. So the outputs will be in run slash, when you're using Google Colab, it will be under run slash segment slash predict. So you can view the output after using a pre-trained model for segmentation, how the output looks like. So this is how it looks like. So here both segmentations and object detection has been performed. So you have a handbag, you have backpack, the dog and the person, all of it is both segmentation and car, on all of the segmentation and object detection has been performed. And so what if you don't want to use CLI versions and you want to use the Python version of doing things? Then you can go for, do it in the Pythonic way as well. Just use a YOLO V8 segmentation pre-trained model, and then predict using the predict for a random set of images. You can also print out the mask, you can print out the bounding boxes, and there are various other parameters as well, and which you can go and explore in the documentation. There are multiple other parameters which the results as, which you can print out and you can visualize as well. And so if you want to prepare your own custom data sets, if you've got images and if you want to prepare your own custom data set, then you can go to RoboFlow and you can create new project, give a name for the project and create a project. And once you create a project, you drag and drop the images here, and whatever images, if you're having it in a local folder or whatever, wherever it is, you can drag and drop the images here. And after you drop the images, it's very easy. There's an annotator tool which comes where you can segment different people, and then you can give the labeling. These are players, this person is a referee, and you can do segmentations like this. So this you can do segmentation. So here after it segments it, there's a pop-up which comes up where you can mention what the class label is. So this is how easy it is to do in RoboFlow. There are multiple other, if you just Google it out, you'll find various other free tools which might be So once you do all those annotations, then you can just export your model, export your data sets. And for exporting your data set, this is the piece of code where you install the RoboFlow. And then you mention what your RoboFlow key is, for which I told you you'll have to go to settings, new workspace, RoboFlow API. You will get your private key. You'll have to put that here. And once you do that, you mention what is your workspace name and what is your project name, and then you can download your data set. So this is how you take a custom data set and do annotations, give labels for the objects in the data sets, and then you can export your data set as well using RoboFlow. There are multiple other tools out there. You just have to Google, find out the free tools, and every tool will have a documentation where you can explore the documentation and find out how to do annotations. So once for the custom training, what you'll have to do is, so here slash YOLO, if you want to do custom training using the CLI version of method, exclamatory mark YOLO, the task which you want to do is segmentations, and the model which we are using, we are going to train it on the custom data set. So the mode is train. The model which we want to use is a pre-trained segmentation model, and we are going to train it on a custom data set. So you just have to give the data set location here in the data tab, and then how many epochs you want to train, and what is the image size, whatever data set image size is there, you'll have to mention in the image size. This is one single line of code for training on your custom data set. This is all it takes to do custom training on your data set. So that's it. You don't have to memorize this. The documentation has got all of it. So you just have to understand what each parameter stands for and give the corresponding values. And once you do a custom training, the results you get, the confusion matrix, you get the model training, all of this will be under run slash segment and slash train. You will get the confusion matrix where you can interpret the results, and you will also get various other result images. And for all of your objects, you will also get the predictions as well in the form of images. You can just visualize these images and see it will be under run slash segment slash train. You will find all the predictions and various other images as well. And if you want to validate your custom model, whatever took a pre-trained model and trained it on a custom data set. Now, if you want to validate this performance, you can do that as well. You can go and take the best, your best performing, your model will be saved under weight slash best.pt, your pre-trained model. You took a YOLO V8 model and you custom trained it on a different data set. So that model will be saved under run slash segment slash train slash weights. So here is where you will find the model saved. So you can do a benchmarking using this model which you trained recently. You can just share the location of validation data wherever your validation data is present, and you can do a segmentation on the validation data set. This is how you do testing on the validation data set. And finally, if you want to make inference on the test data sets, is again a single line of code. This is using CLI method where you mention what is the task which you want to do, which is segmentation, and then you're going to do inference. So it's predict, and your best performing model is present in a certain location, and then you can mention where your test images are present, and this is how you make testing on the inference. And you can just visualize a random image which is present under run slash segment, and you can see how the segmentation performance is. So this is how you do custom training using YOLO version of models. So it's going to be very easy using YOLO version. YOLO version of models have always been better performance at any point of time. But what if you want to explore the other model types as well? We've got it covered. We've got it. We just don't want to restrict the workshop to just one single framework. We want the beginners to be exposed to multiple other frameworks and options available as well. So we'll be dealing with some of the other data sets available, some of the other frameworks available like TensorFlow and PyTorch. So we'll take up next, the third notebook is going to be about the brain image segmentation using PyTorch. So again, I'm going to show if you're going to use PyTorch. PyTorch has got almost every research paper comes out in PyTorch, and almost they've got all pre-trained models for the recent research get your job done in PyTorch is what we're going to see up next. So the image data set also, we are trying to expose you to different data sets so that you're familiar taking up any random data set and getting the task done as well. So here it's going to be a brain MRI image, brain MRI data set. And how do you do segmentations on this data set using pre-trained model and PyTorch? And this is UNet is one of the best performing. It's one of not the best performing. UNet is one of the earliest architectures which has come out in segmentation. So whenever you get started with image segmentation, the first architecture which you will start learning is UNet only. And there are various versions of UNet which has come out, like UNetR, DETR. There were multiple different trans UNet, multiple variations of UNet which has come out currently. So this is one of the earliest image segmentation architectures which had come out. So we have the pre-trained model already available in PyTorch, and we're going to see how to use this. How to use this to do a task, segmentation task, in a totally different data sets like a brain MRI image data set. So Torch has got torch.hub. This is where all the pre-trained models are there. You can just go look for torch.hub. So this is where is the PyTorch hub. This is where all the pre-trained models in PyTorch is going to be here. And you can just check out Vision, and you can find out all the pre-trained models in PyTorch. And how to use this is torch.hub load. You can just do PyTorch/Vision and the model name which you want to use, the pre-trained model name you want to use. And there's also a flag called argument called pre-train. You'll be mentioning if it's true or not, whether you want to use a pre-trained model or not. This is how you use the pre-trained model from PyTorch hub. And there you have plenty of models, pre-trained models for you available in PyTorch, which you can use. There's also another repository called TIM set of models, which is almost every research paper which has come out has been collected and made available there as well. So these are some of the areas where you can explore. So I'm going to take a pre-trained model from the PyTorch hub. And as I already told you, for loading the pre-trained model from the PyTorch hub, these are 2 lines of code. And so this is now I'm going to just take the model where from this location where the segmentation model is available. And the model this architecture which I want is UNet. And there are other parameters like pre-train, input, how many initial features, output channels, in channels. There are various other parameters which you can customize. Or you can just mention the location and the model name alone. So it's not mandatory you should give values for all the parameters. If you just give values for the mandatory parameters, which is the location where the model is present and what is the name of the model and whether you want to use a pre-trained model or not. These are 3 mandatory parameters which you have to give. There are multiple other parameters we can choose. You can check out in the documentation. If you wish to give, then you can give those values as well. And once you do that, I'm going to take a random image from this location, and then I'm going to do a segmentation on this image. So for PyTorch, what you generally do is you'll have to do certain image pre-processing transformations. You'll be first converting the image into tensor, and then you can also do certain augmentations or transformations on the image. So like normalization, or if you want to perform any other augmentations, you can perform it as well. So I'm going to take an image first, convert it into sensor, then do a normalization. These are the things which I do. And I have my model here, the pre-trained model which I have loaded here, which is stored in a model variable. And all I'm going to do is model. I'm just going to pass the input under bash the input where the image is present. I'm just going to pass it, and I'm going to get the output. So it is as easy as this to use a pre-trained model in PyTorch. And so what if you want to use various other models like DeepLab V3 and various other pre-trained models? then again, it's going to be very easy. You'll have to say the location where your pre-trained model is present and the name of the model which you want to use, and pre-train is equal to true, and store the model in a model variable. And once you do this, you can take any random image which you want to perform segmentation on, and then whatever the URL of the image is, you mention it here, and do a basic pre-processing on the images, like converting into a tensor, then doing a normalization, and then you pass this image into the model, and then you'll start getting the output predictions. So this is your deep lab, which is another good computer vision, good performing models and computer vision which you can explore. And deep lab has got multiple different backbones like RESTnet, MobileNet, so you can explore using multiple other backbones as well. So this is a RESTnet variant, but you can try using MobileNet variant or different other a variant of deep lab, which is a pre-trained model. You can experiment with that as well. So this is how you do make inferences in PyTorch. We'll also see how to do it in TensorFlow. See, converting models to ONXS format, I've shared a sample Medium article for doing it in Keras, but that you can do, you will have such utilities available for PyTorch as well. So you can just Google it and you will find the code. You don't have to write anything from the scratch. So that's already available, which you should find out what is the utility and the syntax for the utility and try using it. So most of any popular framework. Okay. So up next, we'll see the next notebook after these two PyTorch is the TensorFlow. We'll also explore how to get things done in TensorFlow. So you can open that notebook, the last notebook here. So this is a notebook. We'll be seeing image segmentation with the UNet-like architecture. So UNet again has got multiple different backbones. So you can use any backbone like RESTnet or any other backbone, EfficientNet or anything. Or Exception is one of the old models which has come out. So this example is about using UNet with an exception style backbone. And so here we are going to use Oxford PET dataset. So this is again exposing you to a different data set, so multiple data sets, so that you get comfortable using the competition data set. We're not restricting the workshop to just the COCO or the benchmark data set. We have seen the other data set formats as well, and we are discussing the different kinds of frameworks. So there is nothing which the workshop endorses, like this is the right way or the wrong way, The workshop is primarily for you if you're a beginner and you have no clue where to get started, to get you up and started very quickly is what the workshop is about. We are not revealing any answers here, and just because something was discussed in the workshop, this is the right way to do. Don't just come to such conclusions. And the next thing is we're going to see how to get things done in TensorFlow. TensorFlow is also a very popular framework, and how to do segmentation using UNet model, but in a TensorFlow framework. And we're also seeing a different data set here. We're going to see Oxford PET's data set. So Oxford PET data set is a benchmark data set. Various research papers use Oxford PET data set for benchmarking as well. So these data sets are present in a certain location. You can use .curl and commands or to retrieve the data set, and use the exclamatory mark or command to actually unzip it. So once you download the data and from these locations and you unzip it, and then you have the input directory where the images are present, and you also have the target category where the masks for the corresponding images are present as well. So Keras has got certain utility functions like, to take these images and then from these directly and convert it into input images, and then corresponding targets. So this is just a bit of a pre-processing using the Keras utilities which are available. And once you have downloaded the data set and stored the images and their corresponding mask in the different variables, you can also visualize it using the utility functions which is available in Keras. So MobileJobs is a third-party library which you can use it for visualizing here. And so this is how the image and its corresponding mask look like. You can just visualize a single image and its corresponding mask. And once you do that, Keras has got, see, in PyTorch we saw, PyTorch, you were taking images and then converting into tensor and then doing normalization, multiple transformations and all that. Same way, TensorFlow framework has got different set of utilities, which for pre-processing and things like that. So here you can, write a class to do get all your pre-processing done. So, if you use a sequence method, then there are certain methods which you need to for sure implement. So here, what we are basically doing it here is we are taking the images and we are taking the corresponding mask and creating a batches of data, multiple batches of data. So if you have the 100,000 images, you don't, process all the 100,000 images in a single go. What you do is you divide the data set into multiple batches and you process in the batches. So that is what you do. So how to get this down things very easily using Keras utilities is what this piece of code is. So you don't have to break your head, write the logic for doing all of this. All of this is available as a part of Keras utilities. So you can just use these utility functions to break down your data set into batches, and in each batch you have the image and its corresponding mask. And once you do this, this is how the exception model is written in Keras. See, most of the time you can all take a pre-trained model and then you can custom train on your data set. So you don't have to write a model from the scratch, because that is going to, if you write a model from the scratch and then going to train it on your custom data set, it's going to take you a lot of compute power. But still, just in case you are having a very good GPU at your home, like A6000, and you're already having 4090, and out of curiosity, you want to do or learn how to write a model from the scratch and custom train it, provided you don't have constraints with GPU, then this is the notebook for you to learn that. But this is not something which I recommend for people who have constraints with GPU. So here the model is written from the scratch and the training is going to happen. So this is what is unit exception model is in Keras. And this is how the model architecture looks like. And if you want to train the model, you just call model.compile method, where you mention what is the optimizer you want to use, what is the loss functions, and you want to save the best performing model. That is also something you can mention, that you want to save the best performing model and how many epochs you want to train. Here it's trained for 15 epochs. So generally it differs from use case to use case. Based on your use case, you can mention the number of epochs and then you train it on the training data set of the Oxford 3-pet data set. And after you do training, you start making predictions, and then you can also visualize your predictions using utility functions which are already available. And this is how the prediction is dog, and this is how the dog segmentation has there. So it has segmented the dog, and the dog is wearing a metal chain that also is being segmented. So this is how segmentation works. So this is about TensorFlow, how to write a model from scratch and then train it on a different data set in TensorFlow. So TensorFlow website has got multiple tutorials and notebooks as well if you want to explore multiple different architectures. And we have covered PyTorch, TensorFlow, and YOLO Ultralytics models. But there are various other frameworks as well which you can explore. And we've also covered how to take YOLO models and convert it into ONX format. There are similar such codes available for you to take TensorFlow and PyTorch models and convert it into ONX format as well. And see, if you want to explore a lot, there are a lot more other architectures which has come out, advanced architectures which has come out, and you can explore architectures like DETR. So this is coming from Facebook research. So if you take DETR, it was one of the best performing architectures which is a transformer based variant. So you can just go use the pre-trained models already there. You can download the pre-trained models and you can get started with it. This GitHub repository also gives you a sample notebook how to do it. So you can make use of these sample notebooks to learn how to use this pre-trained model as well. So how to use it, the usage is already defined here. So these are some of the state-of-the-art models which are based related to transformers. And I've also shared an article which says how to take a Keras model and convert it into ONX. So this is the end of the workshop, and we'll open up for questions now.
There are a few questions on the chat, Usha.
Yes.
I think one of the question is video processing, but we have not given them videos. It's mainly images.
Yeah, you can use YOLO V8 models for video processing as well. And if you're very particular about how to get these things done, I'll share a similar competition which has come out in Kaggle, which is from which is cod detection. Cod is a kind of starfish. So this is a syntax for, there was a competition on Great Barrier Reef is present in Australia. So this is a video-based competition where YOLO models were the winning models here. So this competition happened last year, and YOLO version of models were the top performing models in this competition. So you can just go to the search and you can use YOLO, and you will have YOLO VA train, YOLO full guide, and all this, how to use YOLO version of models for a video-based data set. All the sample notebooks, you will get it here. So you don't have to restrict yourself to this competition. There are multiple other video-based competitions where YOLO version of models were the best performing models as well. And for sample notebooks, you can just go to the search bar and you can search. You'll be able to find a plenty of sample notebooks. Yes, you can use it for videos.
Okay. Questions around performance metrics and evaluation. Usha, can you hear us?
Oh, yes, ma'am. I'm able to see only one question, which is the video object detection. I'm not able to see any other question.
Okay. What type of performance metrics and evaluation tools to be used? She specifically asked for RoboFlow, but any deep learning model like this. Performance metrics and evaluation.
Performance, see, in terms of performance metric, so every competition, the host decides what the metric is supposed to be. So, for example, this is a sample TensorFlow help Great Barrier Reef. So, if you take this particular competition, this is going to be an object detection competition. So, the evaluation metric is given to you by the host, which is the F2 score. See, object detection, they've specifically mentioned this is supposed to be your, evaluation metric, and this mentioned on the competition website. Similar way for this hackathon, you'll have to go to the competition website, and what is the metric which the host has specified will act as your evaluation metric. You cannot come up, this is a competition. This is not a research paper implementation where you experiment with a lot of metric and things like that. The competition, the host has clearly specified a particular metric in the competition page, and that is a metric which you have to use. Because for object detection, there could be various other performance metrics as well, but this is a hackathon, so you'll have to restrict yourself to whatever the host has meant. It's not just for this hackathon, so any competition you go, the host gives you the metric and you'll have to use that metric only. But if you want to go, outside of this competition, publish a research paper and things like that, you're free to explore various other things. And yeah.
So in our competition is mostly MAP and the count of plastic in the given image is been asked. MAP of the train and test data set, and we will run it. You have to show it on the predict data set, and then we will run our validation, fourth data set from our end. I think it's very clearly described in the README document. Please do check for our evaluation parameters. Another question here is that you have provided a set of images to train, test, etc. Can we use any other data set? So for this competition, no, you have to restrict in phase 1. You have to restrict to the given data set only. Is there anything else? Yeah, is it possible to perform a classification task using segmentation models such as UNet?
See, for classification tasks, see any backbone, generally UNet model is, built for segmentation tasks. So when there are such a great performing classification models, because classifications, anybody who wants to get started with computer vision, the first use case which they will deal with is image classification. So compared to object detection and segmentation, image classification is much more evolved. So there are better performing models like efficient net, and there are better performing models which in classification which you can make use of. There are a lot of transformer based variants which are available for classifications as well. So you can make use of those models which are exclusively built for classification. So you can go and you can check out the PyTorch hub where there are multiple classification models which will be available PyTorch hub, or if you also can go and check for papers with code. So the way to find the benchmark models, under any of the use cases to go check in papers with code. So you can click on browse the state of the art. So here you've got semantic segmentation, image classification, object detection, and things like that. So you can click on image classification, and then you will have various other benchmark data sets which are coming up, like ImageNet, Safar 10, Safar 100, and things like that. So, for example, ImageNet is the data set you want to, look at various, classification models, how they perform on ImageNet. So here you've got it, the multiple classification models performance on ImageNet is given here. So you can see it is ranked based on their performance and the year at which these models have come out as well. So Basic, this model has come out in 2023. And so I'm going to click on this model. This is a related research paper of that model. So this basic L is some symbolic discovery of optimization, whatever, just 2023 paper. And you have the implementations available in TensorFlow, you have the implementations available in PyTorch. So any paper, most of the paper will have links to the paper implementations as well, where you can make use of these. They would have released the pre-trade weights along with the paper implementation, so you can just make use of it. This is how you can go, you experiment with the recent architectures which has come out in, this has come out in 2023, and model soup has come out in 2022. So you can go, the top 10 architectures is something which you can experiment with. So when it comes for image classification, a lot of people experiment with VIT, which is vision transformers, and that is very famous. EfficientNet is very famous in terms of convolutional neural networks. So these are some of the models which people experiment with image classification. And if you want to, at any point of find the top 10 performing models in a particular benchmark data set, then papers with code is something which you can go and explore.
Is there an ensembling possibilities, multiple good performing models?
So when you have multiple good performing models, you can also do, ensembling of all these models. There are multiple other techniques like ensemble learning and boosting, and where you can combine the performance of multiple models as well. And so that is one thing which you can try. Or for the given performance metric, you can find out which is the top performing model. You can just stick to one model, or you can try to do combine multiple models in your architecture as well. So the way you do it is you can go to Kaggle for looking at how to do ensemble for object detections, how to do for ensembling for image detections, and all of it you want. So Kaggle has got a huge repository of any competition. If you take object detections, you will have at least some 30-40 object detection competitions, and you'll have some 30-40 image segmentation competitions. So you can just give to leaderboard and you will find the top solutions already available here. So the top solutions is already available. So this is a solution. So you can click on this top solution and you'll find their architectures which they have used for the winning solution. So most of the winning solutions, it's not just one model. They would, they would have tried multiple models. So if you use here, we did ensemble these 6 YOLO V5 models. So each of the YOLO V5 model has got different hyperparameters, and they've done an ensemble of the 6 V5 models. So the first top 10 prize winning people are supposed, according to Kaggle rules and regulations, they're supposed to open source their script. So they would have open source a script which you can go and check there's an
Another question.
efficient
Yeah.
solution.
Another question around should we create labeling in YOLO format? Labeling.
So it depends. You will do labeling in the format of which the format in which your model accepts. So if you take YOLO models, they accept labeling in a specific certain models, which if you go to the Ultralytics website, they would have mentioned what kind of format the model accepts. So you will have to check out whatever model you are using and what is the input structure that particular model accepts is what you have to use.
Okay. There is a question which is coming recurrently. In our README file, we have mentioned that 65% of MAP is a minimum requirement. Is this on both train and validation dataset? So the answer to that question is, yeah, minimum 65% MAP on the train and test dataset. On the predict data set, it is your new model that you can definitely that could be the base. The README file does not mention the range of IOU thresholds over which the MAP needs to be calculated. Last workshop, we had mentioned that we need to use a range of thresholds for IOU. So I think this is a recurring question that which is coming up. Usha, if you can throw some light.
See, no competition will give you exact IOU threshold which you have to use. You will have to experiment. That is an experimentation which has to be carried out from you. You have to do a range of thresholds. You
Yeah.
can go to any Kaggle competition. You can check the evaluation metric wherever MAP is given, and you can see if any of the competition has given you a threshold or not. No, none of the competitions will have thresholds, and no competition host is going to give you a threshold. This is something which you have to experiment, find out, so that you win the competition. Yeah.
Okay. Yeah, so we cannot give any definite answers to any of these questions that sometimes there is a question which I'm trying to understand. Since RoboFlow shuffles the whole data set and separate into randomly trained, test and predict, can we export each train, test and predict data set and export separately so that it does not get shuffled and later converted in the format using a code? Yeah,
This is very specific to RoboFlow. So you'll have to explore the LogoFlow documentation. There'll definitely be a lot of parameters which will help you, there'll be a parameter where which will tell you, ask for whether you want to shuffle or not shuffle. So there, whenever for such tools, there'll all definitely be parameters, and that's an evolved tool as well. It's been there for some time. So there will be definitely an argument where you can choose as well. You just have to explore the a tool which whatever parameters it offers, and we are not recommending in any way that you should use RoboFlow is just one such tool. There you can use any of the tools which is open source tools which are available, and check out, read the documentation, so you find out all the arguments and customization you can do on that tool, and you should be able to get it done.
There is another question around shall we do data augmentation, because in the given data set we have given 70 as train, 10 as 30 as the test and 10 as predict. Should we do data augmentation?
So data augmentations is generally recommended whenever there is very less data sets available. So data augmentations are generally recommended, but that's again your choice. It's a personal choice with regards to models. So it is like revealing, these are model hackathon secrets. and every individual will have, the winner will have a secret. They would have performed certain augmentation techniques. Some people without augmentation, they would have got better performance. These are recipes which will contribute to your winning or not. So these are secrets which we can't say, like, to use data augmentations or not. But generally, whenever there is lesser data set, in competitions, we use data augmentation techniques to compensate for the less training data set. But whether you should mandatorily use or not, something will not recommend. That is for you to figure out.
Okay. Question around labeling should be done only for plastics, or should we need to label other objects too? In phase 1, we request you to label only plastics. If you cross and reach phase 2, then you are free to label other things. But phase 1, we will keep it simple and plastic only. I hope that's clear. Okay. So I think we have taken more or less every question, Usha. There are a multiple set of questions around the hackathon itself. So if you don't mind, I will share quickly the screen and then tell them that how to go about, right? Is that okay?
Sure.
Yeah, okay, fine. Okay. So once you are here in our website, which is if you can share this. Okay, let me only do that. So this is our website. Please go and sorry. So this is where you will get more. I think it's a wrong link. Nikesh, please check and do
Yes, ma'am. I'm sending,
because I
ma'am.
think it is your, yeah. Okay. So this is where once you sign in, you will be in this site. You have now, I think the phase 1 time is only 9 days. This is where you will get a data set. So if you open this, you will get under this. Okay, let me not get in because I may have to. So under data set, you have train 70, test 30, predict 10. This order must be retained because at the end of it, predict, you will have to give us these results on the predict data set. Now under this submission templates, here under this, one second, yeah. So under this, we have a document. So please read this. In this, we have put in what format the final CSV has to come in. So if you see here, this is the answers that we expect. Whether in the predict data set, you are able to predict the plastic correct or not. What is the actual count of plastic in this image number? And what is your predicted count? And the difference between actual and predicted count is the error. Percentage of error you can calculate. And your MAP train. This is going to be constant because train data set, you would have got an MAP. That's what you should write in all the all the cells. And same for test. But here we are expecting that you have an MAP of 0.65 and above and geotag also, right? There is a way in which that you can programmatically run the geotag from the meta description available. So this is all clearly discussed here in the document, how to submit, what to submit, etc. So please go through this document. You will get. So so you are here. You are on this website where you can get all the details, right? I hope most of these questions have been answered. Submission templates, you have this ONNX format, which Usha just mentioned. So convert your code into ONNX. Share it with all the .txt format. All the dependencies must be clearly given so that we can run it. And we will always look at how easily we can run your code. So please ensure that you give us these dependencies in very clearly mentioned. There must be a CSV template, and then there must be a slide deck. You can demonstrate the video yourself and record that video. All these things together, you must give us your Google Drive or wherever that you are putting. This is where you can upload your answers. We have hardly 9 days to go. So we request all of you to go through all the requirements. You can always put your queries in the chat or in the Discord to get to the submission part of the hackathon. Somebody is asking, what is metadata, right? So if under the, we are not going to show you the image now, but we are hoping that you have the image been downloaded. This is a drawn image. So if you check each image, you can right click and get into the properties. There will be meta description of the entire image characteristics. One of the property is the lat and long of that image, right? So it is available on the image. It is a separate activity. It has nothing to do with modeling. It's a separate one. This is because our intention is to develop solutions based on the plastic density of the geolocation. If we get, because this is mostly it is taken from Vietnam, the Saigon River, but say if it is at Bangalore, then we need to get the geotagged location of the plastic. It's very important for the final solution, right? That's why these details have been given. Any other questions are there on the what is, so metadata is it's available on the image. Geotagging, you have to understand. Maybe Usha, you want to say something about geotagging?
No, ma'am. I've not seen the geotags as such, so I can't comment much about at this point.
Okay. Yeah, so it is already there. Your lat and long is there on the image. That if you programmatically put into a small line of code, you can geotag it directly to the location. It is like Google pin, right? You have a Google pin, so you can pin it up on the image and put it on the CSV file, right? So that's again an experiment. Okay, I think we have got a kind of excellent questions, and Usha, you have been amazing. I know in very short time you discussed YOLO models, you discussed PyTorch, you discussed TensorFlow, you discussed on some of the state-of-the-art algorithm they can check on, say Kaggle and other places. At least those who are still experimenting on what to start or where to start, I think they have enough enough meat in their hand to go and chew on. So I hope this has been very useful, right? So thank you so much, everyone. Looking forward to a lot of interesting solutions and interesting models in the hackathon. Thank you so much. We will keep the dialogues open in Discord. Thank you. Thank you, Usha. Thank you.